Okay, probably we will get started. Thank you, everyone, and good afternoon. And we are very pleased to launch the professorial talk series in the School of Engineering and Technology. So this series, we believe, will showcase the expertise of our professors and our distinguished academic leaders to the wider community and also our industry partners as well. And we're very glad to see our guests from other universities joining in today as well. And for our inaugural talk, we are delighted to feature Professor Guido Governatori for this first talk. And Professor Governatori joined CQUniversity in late 2024. And his research area is in the application of artificial intelligence in legal and compliance domain. It always fascinates me how AI can be applied in everywhere. He holds his PhD in legal informatics from University of Bologna and brings decades of experience working in university and research organizations like CSIRO. And also, of course, we are very honored to have Professor Nick Klum, Vice Chancellor of CQUniversity, join us today. I think Dr. Jessica Sun, our newly appointed Director of Research, she has accepted as well. She might be already here or she will be joining us very soon as well. Thank you very much for joining us. And I would like to thank Santosh Weibo for organizing this talk series, and of course, Dakota for helping to organize it. So before we start, we would like to acknowledge our traditional owners and custodians of the land and pay our collective respect to past, present, and emerging leaders of all the First Nation people in Australia. Nick, when you are here, we have to ask you to say a few things, Nick. So please, if you want.
Thank you, Robin. That's very kind of you. For those of you here just before the hour, I'm going to apologise because I'm eating my lunch while this is happening. We're in the middle of all sorts of things going on this afternoon, but I just didn't want to miss this presentation. I'm really fascinated. So thanks, Guido, and looking forward to your presentation. But just ignore me. You guys talk amongst the experts, okay?
Thanks. Thank you very much, Nick. So I'll hand it over to Guido. So Guido, please.
Thank you, Robin. Let me share my slides. Okay. Okay, well, first of all, I'd like to thank all of you for being here and for this opportunity. And today I'm going to give a very introductory presentation on what I call computational law. However, just to start my presentation, let me join Robin and acknowledge all the traditional custodian of the land of all over the places where we meet, and also pay my tribute to the elders, past, present, and emerging. Okay, now let me start with a small example. Again, it should be very simple for people trained in legal reasoning and in the legal domain. So suppose that we have this small fragment of a privacy act. So in this case, we have a few sections, and essentially the gist of this example is that there is one section that makes forbidden to collect personal medical information. For the sake of this example, let us assume that there are no doubt, it's completely clear what personal medical information is. And then we have that according to this fictional act, it is forbidden to collect personal medical information. However, it is a defense against the prohibition if the collections was accidental, and then an entity recognized that they collected the information illegally and destroyed information before being able to make any use. However, there is also an exception. So essentially, an entity is permitted to collect personal medical information if there is an authorization from a court to do so. Finally, we have the final section, and this section forbids to collect personal information. Again, for the sake of the argument, it is completely clear what personal information is. However, there is an offense or also a defense in, let's say, in legal terminology. And it means that an entity is permitted to collect personal medical information. It's permitted to collect personal information if they were permitted to collect medical information. So what about if you have an entity? The entity collect at the same time medical information and personal information. They recognize that the collection was illegal, and then they destroy the two types of information. Is the entity compliant or not? So this is the type of problem we want to solve. Now, again, if you ask a lawyer, the answer will be, well, the typical answer from a lawyer, it will be, it depends. However, if you really force them to give a positive or a negative answer, they say, well, the collections, the behavior was illegal. It wasn't complying with this particular act, simply because while there was an illegal activity, so the collections was illegal, there was a remedy for the collection of the medical information, but there was no remedy for the collection of personal medical information. So essentially, what we want to do is to be able to build computer systems that are able to provide us the right answer, so that in this particular situation, we have a violation of this particular condition. Okay, now let me move, and essentially let's move to the core and let's say the technical component of today. It will be a very light presentation from the technical point of view. I'm more interested in the general idea and to show what it's possible to do, and then at the end to show some of the applications we have built over the years. And let me start with what I call computational law. So what is computational law? So computational law, in a very short term, it's just the use of formal method, in particular logic, to provide a formalization, a computer formalization, a computer representation of a normative system. Then after we have that particular encoding, we can use it to determine what are the legal requirements in force. So what are the obligations, prohibitions we have to obey in that particular situation. And then, given a situation, since we know what are the legal requirements that apply to that particular situation, we can determine whether we have some violations or we are complied with it. And then also, if there are some violations, we can identify whether there are some compensatory clauses and whether those compensatory clauses have been satisfied or not. So this is the general aim. And then I will give a very, very quick overview of how to do that. Okay, but before moving to the technical component, I want to provide a motivation. Why do we want to do that? Why do we want to work on computational law? What is the goal of what we are doing? Now, the deepest aim is then we want to develop and deliver technology that allows us to identify the regulatory burden on government, business, and individual, and then to use ICT technology to reduce this burden. Now, let's see how it can be applied in different domains. So on one side, if we have this underlying technology, regulators can move their rule books, their legislation from an analog version to a digital version, a version that it can be processed by machine. Well, then if we have them implemented, then agencies and other government entities can apply many different techniques to identify whether there are issues of red tape, to understand what are the impact of possible modifications, and then it will provide a tool to reduce the time to get to market. Again, probably if we're speaking of government, it's not probably correct to use the term market, but essentially it's to see how they can reduce the cost to deliver services to the citizen and at a reduced cost and with a better throughput. But also the technology can be used to third party. So what we can do, we can envisage a new economy where we have a version of the legislation released in a digital format, and third party will build applications on top using their domain knowledge, their legal expertise, and then they can provide services to third party at a reduced cost and with better output. So essentially, we can have an improved to the access of justice. Businesses will have tools to determine whether they are compliant and also to reduce the red tape. Also, it can improve the transparency on the legal processes because essentially everything will be accessible, and then you can have a proper explanation, and every time you have a conclusion, every time you have an outcome, you can have a full justification, and you see all the steps that lead to that particular decision. Now, why do we want to do this? Now, if we look at the current state of in the legal domain, compliance is difficult. And then there are many, many reasons. So we will have many different pieces of regulation, different versions of the regulations, different jurisdictions, and so on. So a case study where we're looking a few years ago, it was, well, what about if you want to operate a food van on your local market? And you want to move from Brisbane to Gold Coast. Well, if you just want to operate in Brisbane, you have to comply with 35 different pieces of regulation. Oh, now, if you want to move to the Gold Coast, you have an additional 5, simply because you cross the boundaries between local council. And then, in general, the food van operator, it's not a lawyer, so it's not aware of all legal requirements he has to satisfy or they have to satisfy. So what we want to do is to provide tools where business operators, individual citizens, are able to access some support to help them to comply with the legal requirements that they apply to them. Now, here are some figures. Unfortunately, the data I have is a little bit outdated. It's before COVID. I wasn't able to find more updated and reliable data, unfortunately. Now, here we have a couple of official sources. So, in US, the cost of compliance before COVID, just before COVID, was approaching $2 trillion per year. Or in Australia, we were more lucky. It was only about $250 per year. That I think it's the 2019 data, but it was only 190 in 2018, the year before. Now, if we ignore the differences in GDPs across different jurisdictions or different countries, there is a study by the OECD, and they estimate that the cost of compliance in OECD countries amounts to anything between 10 to 15% of the GDP, which is something absolutely astronomical. Now, in Australia, about 1 million people works in compliance and compliance-related area, and then this is 10% of the workforce in Australia, and it's growing. Now, just to see what is also the impact of compliance, now consider this other example. Typically, in a financial year, the Australian government awards about over 60,000 contracts, and the estimated value of those contracts is about $60 billion per year. Now, typically for each contract, there are 10, 12 bidders, and only one of them will be awarded with the contract. However, all the bids have to comply with the procurement regulation, which is very complicated. And then if some minor mistakes are in your applications might be discarded without going in the actual merit. And only one of them, out of 10, 12 will be awarded. So the other 9, 11 will do the work for nothing. And essentially, is it possible to help them to reduce the cost and to have a better outcome and to ensure that when they submit an application, the application is according to the rules? Now, We had done many experiments and projects in the past, and we estimated that the use of computational law and regulatory technology, a broader umbrella, can reduce the cost of compliance by 30%, which is quite big. Also, there is a study from the Department of Primary Industry in New South Wales, and they estimate that if you are able to automatize 5% of the New South Wales legislation, the savings are equal to the total education cost for New South Wales for education per year. Again, it will be a very big improvement, and money, government money, could be better spent. Now, what is the goal? What we want to have at the end, it's to have legislation that is represented in a dual form. We want to maintain the natural language, the natural way it is written right now, so in English, but also we want to have the legislation available in a format that is processable by computers. What we want to do, it's in particular, for the computer version, we want that the computer version is at the same time human understandable, so people reading it can understand what is the goal, what is the intent, and what is the meaning, but then also computers can process it in an automated way. They can determine what are the eligibilities, what are the mandates, what are the calculations, and what are the actual provisions in force, and what are the legal requirements in force in a particular situation. Now, what's happening around the world? So we can see that several countries are already looking at digital legislation or implementing some form of legislation as code in their jurisdictions. Okay, some are usual suspects. I would say probably Estonia and South Korea, but also there are some other notable exceptions. Well, UK was partially forced to take this approach after Brexit because they had to rewrite 90% of their entire legislation, so it was a good opportunity for them. And we will say something about Australia shortly. Now, what is the idea of the platform we want to build? Okay, now, what we want to do is that, well, we follow the normal government and parliamentary iter to approve and to discuss the regulation. And then after we have that the legislation it's written, let's still assume that it's written in natural language. Then what we want to do is to have some mechanisms. At this moment, this mechanism will be done by clever and trained humans to translate the legislation from natural language into a logical format, something that can be understood and processed by a machine. But at the same time, ideally, we want to have that logical, that computer version, it's also somehow endorsed by entities, authorities that have the power to enforce it, or they have any kind of power of them. Okay, then what we do, we can build on top some reasoners, and essentially, for every case, we can understand what are the requirements that apply to a particular case. Let's see a little bit in a slightly more detail. So, as I said before, we start from this logical representation, and then essentially we can do a logical analysis. Again, since it's written in a formal language, from formal language and computer science, we know how to do many different activities. We know how to identify whether there are inconsistencies. There are techniques to see whether there are some loops. We have techniques to see whether there are some conditions that are redundant, and so on, and many more. Well, but then, as I told you before, after we have deployed this, let's say, this foundation, this database of rule sets, then what we can do, we can create APIs, some interfaces, and the interfaces can be consumed by many different applications. And then you can build many different applications to provide services or to provide benefits to businesses and citizens as well. Now, what is the state of digital legislation in Australia? Just before COVID, Australia was at the forefront of the research in digital legislation and computational law. Now, in 2021, there was an interim report by the FinTech RegTech Committee, and there was a very strong recommendation. And the committee recommended the Commonwealth government to establish a Commonwealth hub, an innovation hub on rule as code, just to investigate how to advance legal coding and to see how to achieve digital legislation. Unfortunately, there were no progress since 2020 in Australia. Okay, so I give you the introductions, I give the motivation, and now we can move to the, let's say, to the technical component. Okay, now, so what we want to do, as I told you before, is we want to have a logical, a formal, computer processable representation of a normative system. Again, we will take a very, very broad definition of a normative system, and then for us, a normative system, it's just a set of clauses, it's just a set of norms, it's just a set of legal rules. Again, we don't really care what is the source. We can go from fully parliamentary act, we can go to regulations, we can go for policies, we can go for contracts. We don't really care. Essentially, it can be the techniques, it's general enough that can be applied for a very, very broad set of applications. And then essentially the key point is that the rules or norms are modeled as if-then rules. And again, we're not going to too much details here. And essentially we will have expressions in this format. We will have some conditions, A1 to AN, and which will be the if part. And then after the arrow, we have the then part, which will be the legal effect. Technically, we can distinguish between two types of legal effects. Some norms, some clauses in a normative system will just provide definitions. So what is the definition of an adult person in Australia? Other conditions will just provide what are the normative effects, so what are the obligations, permissions, and prohibitions depending on those particular conditions, and it will be the legal effect in this sense. Now, one of the key points of when you want to model normative system and legal clauses, we have that norms are divisible. Or in other terms, very often you have a baseline condition and then you have a very long list of exceptions. You can have also longer list of exceptions. And well, if the lawyer did their job properly, you will have exception to the exceptions. This means only lawyer will be able to understand the intent and the conditions. Normal humans typically won't. And then essentially, this is what we want to represent, and we want to have some formalism that it's able to do that. Again, here to understand a little bit better what are the core notions, we can consider that we want to have obligation. An obligation is something you have to do, and if you don't, we have a violation. We have prohibition, very similar. It's something that you have to avoid, and if you don't, then we have a violation. And finally, we have permissions, and essentially, there are different interpretations of permissions. We will stick to a very basic definition. And essentially, we can say that something is permitted if it's not forbidden, or we don't have the obligation to do the opposite. Now, one of the other important aspects is that obligation and prohibitions can be violated. And then many different types of normative systems have also condition clauses that are called compensatory clauses. So essentially, they provide techniques or actions or activity that compensates for the violations. And again, this is something we want to represent. Okay, now again, bear with me with another legal example. So let us suppose that we want to do something about, we want to encode the section 29 of the National Consumer Credit Protections Act. And then as you can see, here you have a baseline condition. And essentially, this condition specifies that it's forbidden for a person to engage in credit activities unless the person has a permit and authorization that allows to engage in credit activities I skip section 2, which is essentially, it specifies what is the offense and what is the defense. And then you have section 3. And then section 3, it's a very long list of offenses called defense in legal terminology. And essentially, you say that a person that normally it's not allowed to engage in a credit activity can do if acts on behalf of another person, and the person, it's an employee of a director, and many, many other conditions. So if I remember right, the section 3 goes for about 3-4 pages. And then there is another section, another subsection for another 3-4 pages where you have the exception to the exceptions. Now, how can we model this using the idea of computational law? Well, again, we will have expressions something like this. So you will have rules, you will have the if condition. So for example, for R1, we have if somebody is a person represented by this term here, then you have that something, a particular activity, in this case, a credit activity, it's deemed as forbidden. And then again, we can go on and to have many other conditions. So if a person has a credit license, then the credit activity is permitted. And again, we can have more. Finally, what we can do is the mechanism to implement the exceptions. We can specify that one rule, it's stronger, defeats of overrides another rule. So R2 in this case, it's stronger when they both apply, then R2 take precedence over R1, and same R3 take precedence over R1. Again, as I said before, what about if we want to model in an efficient and natural way, also in a technical way, when you have a violation and sanctions? This is it's a more technical problem because the deontic logic, which is part of computational law, had problems on modeling violation and sanctions. However, the system we propose avoided those problems and it solved those problems. So what we can do, we can recognize that we can have something, expressions, norms like this. So if a particular condition, then something is forbidden. And also if I say if something, then something else is obliged. This is technically, it's called a contrary to duty. And then again, if we want to represent a contrary to duty, we can go for this. But if we want to model that something else can be compensated if something, then essentially we can write in our language expression like this. So we have created a formalism which is called the feasible deontic logic that allows us to model and represent and playing with regulations in a natural and efficient way. So it combines one non-monotonic logic called the feasible logic and some deontic notions, and then it provides techniques for a natural and efficient representation of exceptions, as we've seen, for example, from section 29 of the NCC. We have to model them. Also, we have to model obligation and prohibitions, and again, the logic allows to do that in a very efficient and natural way. Also, we have created several implementations. Some of them are very optimized and they're very, very efficient. And finally, we tested the applications and we have validated the use of the logic with many real-world applications and projects with partners in the real world. So let me start with just an illustration on one case we did a couple of years ago. I did with some colleagues with La Trobe University, and also there were some overseeing from some federal Commonwealth agency. Now, essentially, it was about the modeling and encoding of the spent conviction schema in Australia. So spent convictions, it's the discipline in Australia that allows one person to define and to identify when a person it's allowed not to disclose information about previous convictions or when a person has to disclose that type of information. Moreover, there are also conditions that if a third party knows that you had a previous convictions. It defines conditions when that party cannot disclose that information, or when that party has the obligation to disclose that information. Now, this is very, very common in Australia, as we will see in this slide here. So typically, the spent convictions, it's one of the things that it's look when you submit, let's say, a permit to work with children, or this type of permit or similar consideration. So the spent conviction in Australia, it's regulated by Part 7C of the Crimes Act. Also, the state and the territories have their own legislation and schema, not all of them. Now, what is important that the Crime and Intelligence Commissions runs the National Police Tracking Service, and in 2017, 2018, they were processing over 5 million checks per year. And 1.5 were referred by states and territories, and it was increasing by 10% compared to the previous year. So essentially, every time I apply for a white card in Queensland, or a blue card in Victoria or other states, they have to run this type of test. Now, the worst part is that those tests are done manually. And in discussions we had with them, they estimate that 80–90% of those checks can be fully automatized and can be done in an automated way without relying on some police officer to really look at them in detail. And then 10% must be examined manually by people with some domain expertise. Can we help them? So that was the aim in that particular project. So essentially what we did, we see whether it was possible. So essentially we look at the Part 7C of the Crime Act. So essentially what we did, we encoded parts from 1 to 6. We decided not to look at part 5 because it's really the administrative part of this one, and essentially it does not give the specific conditions when a person or an entity is asked to disclose or it's forbidden to disclose. So essentially it was not relevant. Part 1, it's about the interpretation. 2, 3, and 4 are essentially when a party has the obligation. And finally, 6, it's what are the exclusions or exceptions. Now, what we did, we use our logic, and essentially it was the feasible deontic logic. So essentially, and also we use some implementations to play with them. And then essentially the first part of the project was to see whether it was possible to use the language, the formalism, to encode this particular part of the crime code. And essentially it was positive. And then essentially the other aspect, it was whether it was possible to model in a natural way. And the answer was yes, it was possible. And as we will see in the next few slides, we will see there are close correspondence between the way the clauses, the norms, the rules in the Act are formulated and the way we represent in the formalism. Again, it's not important to look at the details. And then essentially what you can see that here we have, this is the example from the interpretation part. So essentially we can see that in the language we have one first part where we declare some symbols. We have what is the meaning in natural language, and then also we represent them as some rules. So if we look at the first one, then essentially the meaning of this line here is, okay, now if there is a person and the person got a conviction, then this count as a conviction for the purpose of Part 7 of the Crime Act. And again, similar conditions here. Then we look at another part, and essentially the other part was about, well, what are the obligations, or what are the permissions, or what are the prohibitions? In this case, we look at section 85.85ZS. And then essentially we can see, again, we have a very similar representation. There is a let's say there is a similarity, and I'm not claiming anything more than that at this level. And then essentially we can say, well, if there was a person and there was a pardon or the person was wrongly convicted, then the person is exempt. So it's permitted not to disclose that it was charged, and also it is exempt from that it was or they were convicted. Again, also we can go on and then we can go for the exclusions and essentially the exceptions, and we can see, we can model exceptions in a similar way. Again, it's not important to see the technical details. Again, the important part here is then there is a similarity between the two formulations. Okay, now let us suppose that we have a case. What about if we have a case where one person, A, got two convictions for insider trading? It was done in 1998, and that person essentially was not in prison, and it was released on a good behavior bond for 2 years. Now, this person applies for an appointment as a management consultant for the Australian Federal Police. Question: is A exempt from disclosing the charge or not? Okay, what you have to do, we have to know exactly what are all the conditions, but then what we can do is just to look at this screen here. So in this screen, essentially, we were implementing the system. In this panel, we have the formalization. So essentially, what are the conditions, the formalization of the outcome of the sections. Here we have the case data. And finally, so we can click a button, and on the other panel, we get the output. So in this case, we have that, okay, then the person was released on a good bond, so it was not in prison. And then essentially what we can see is then, since the person wanted to engage with the federal police, the police, then essentially it's going to work with a law enforcement agency. And then even if a conviction was spent, so it's a conviction, it was before, it's after 10 years from the convictions, but then when a person engages with a law enforcement agency, then they have the obligation to disclose the charges and the convictions. Now also, other entities that are aware that the person was convicted have the same obligation, so they are permitted to disclose the charge and the conviction. So essentially, this can be done in an automated way. All you have to do is to provide the fact of the case. So here we did a very manual validation. We ask, in the project, we had 3 retired judges. So we provided them with a small number of cases. And surprisingly, the 3 judges agreed on the outcome of the cases. And also, the outcome of the case was the same as the outcome predicted by the tool. Again, it was not statistically significant, but it was encouraging going on. Okay, so now that we show essentially what we can do, I want to just give a very quick overview of some of the applications we've built over the years. So here I want to give you the list of some of the application and project we engaged in the past X years, made long. And let's see here. Now, one of the application, not necessarily the first, was to build what we called regulation as a platform. Essentially, it was a set of tools that allows you to encode legislation and essentially to reason with them. So essentially, we created some editors, and in the editor, you were able to represent the legislation. And then also it provides some visualization tools. So essentially, here you can see what are the dependencies among the rules. And also, well, if you want to automatically create some modern art, you have another visualization tool. And essentially, you can see what we call the dependency graph. And also, well, besides creating modern art, it is quite helpful to analyze and to evaluate what are the possible impacts if you want to have some changes. So here you have to define, it collects all the terms that appears in your rule sets, and essentially you can see how connected are the different terms. So what about if you want to change the definition of one particular term in your legislation? then essentially you can see how many other terms will be affected by this particular change. So essentially, it will be a tool to create the legislation, but also to have visualization that allows you to understand what is the complexity and what are the connections between the different parts of your legislation and regulations. Now, this is the application on business process compliance. This was the first real applications we built. And essentially, the aim here, it was, okay, now suppose that you are an enterprise. In your enterprise, you run business processes. Many activities are regulated. So what we want to know is whether your processes comply with the relevant regulations. And then you want to know before you deploy your processes. So you design, you give it the blueprints for your processes, and then you want to know whether they are compliant with the relevant regulations or not. And if they are not compliant, you want to know what are the part of the process that fail to be compliant. So here we did this here. So essentially we model the regulations in standard business process modeling notation, which is an industry standard. We formulated the regulation. So this example here, it's about know your customers. So this is one case for anti-money legislation, and we were working with one of the big banks on this project, and also we were looking at their processing on how they onboard new customers. So this, it's a simplified part of their process. It's not too different from what they really do in reality. And also we've modeled section 4.3 of the anti-money laundering legislation of OSTRAC 4.3. Then essentially, after we have this picture here, we can click a button, and then we discover that this process here, as defined here, it's not compliant. And then we can identify that there are two steps where there are non-compliance issues, and the tool is able to identify what are those compliance issues, and then essentially can provide a report to the end users, and then it's up to the end user to see how to address the issues. Now, we tested this particular application with a couple of industry scale projects. The biggest project was compliance of telecommunications compliant processes, and we check against the Telecommunication Consumer Protections Code. So that was a quite large project. So we had to examine processes of 50, 60 steps, very complicated with many loops and so on. Also, the regulations we encoded was about 30 pages. Just the section on complaint was 30 pages. And we proved that technically it was successful. We were doing this project in 2012, and unfortunately at that time, let's say the industry was not ready for this particular approach. Now, this is another project we did in collaborations with INRIA in France. And what is the underlying problem? Now, suppose that you have a software house and you want to build some application. Very, very often, you work with many software libraries. Each software library has some licenses. Typically, they have a license. So, is it possible to use different libraries and to put them together in a particular package? So what about if they have different licenses? Are those two licenses compatible or not? And what are the conditions you inherit from using the different licenses? So essentially here, it was exactly this particular problem here. So you start from analyzing the licenses for the individual components, and then essentially the tool, it's able to understand what are those licenses, and then to put together the different conditions, and then to see whether they are compatible. And also they can identify what are the conditions, the licensing conditions that apply to a piece of software combining multiple libraries with all different licenses. Now, this is a project we started and we are currently working on. I'm working with colleagues from the University of Bologna and the University of Turin. also my partners in Bologna are part of, actually, they are leading a large European project about the establishment of sandboxes, the national sandboxes in Europe. And they're defining the standard to check AI systems for compliance against the EU AI Act. So what we propose and what we did was to look at the life cycle of the development and deployment of AI systems. And essentially, we did a formalization of some sections of the EU AI Act. And also, we analyzed, using the business process compliance technology, whether some parts were compliant. So at this moment, we focus on the development phase of an AI system, and we proved and we demonstrated that the methodology we use, it's successful. It's able to identify whether there are compliance issues or they are compliant with it. Now, this is another project, and this was done in collaboration, actually. Most of the work was done by one of my PhD students, and it was in collaborations with CQUiversity at QUT, and essentially it was on autonomous vehicle. So what we did, so this is essentially just a couple of screenshots of some of the experiments we did. So what we did in this particular project was we encoded the overtaking clauses of the Queensland road rules. Then we generated a set of test scenarios corresponding to more or less common scenarios you can encounter on Queensland roads. And then for each scenarios, we created a set of cases. Now, for the set of cases, we distinguish between what we call clear cases and borderline cases. Now, essentially, one of the point is that in the road rules, you have some terms that are left to the interpretation. For example, is there a safe distance between two vehicles? Or do you have a clear view of the road in front of you? Do you have a clear view of the approaching traffic and so on? So what we did the encoding of the rules, and also we looked at the state-of-the-art literature on traffic rules, and essentially we encoded parameters to compute safe distance, clear view, approaching traffic, and so on. And then essentially we generate cases where we were very, very close to thresholds. Those are the borderline cases for those parameters. And then the clear cases, it's where there were large margin on the thresholds. Then essentially, after we executed the test cases on a simulator. So we can go to the previous slide, and essentially here we were able to replicate those situations. The simulator we used was it was a true car on hydraulics. So essentially the actual behavior of a car. It is used for testing traffic conditions and many other aspects. So it's a full car with a couple of $1 million bill when they built that simulator at CQUiversity. And then essentially we created the simulation. Well, then for the evaluation, what we did, we enroll a number of drivers. We divided between expert and regular drivers. Expert drivers were driver instructors. And essentially, for each case, we had a number of cases. And then each driver evaluated a number of cases. And then they have to say whether the maneuver was legal, according to their interpretation of the road rules, or the maneuver was illegal. Moreover, they had to provide the explanation why they think the maneuver was illegal or legal. Then finally, we compared the automated evaluation with the evaluation given by our tool. Now, what we have is then we have an agreement of between 85 to 90% for the clear cases and about 55% for the borderline cases. Now, so the idea is that, well, you should get ideally 100% for the clear cases, and you should get 50% for the borderline cases. So suppose that the safe distance between your car and the car in front of you, it's 10 meters. A borderline case is it's 10 meters and 10 centimeters. So as a human, are you really able to understand whether it's below the threshold or not? So it will be it can go either way. So what about if instead of 10 meters, it's 30 meters? That it will be a clear case. Now, also, when we look at the reasons why they provide a different answer from the system, in most cases, they had a wrong understanding of the road rules, or they missed some other point where not. So essentially, if we remove human errors, the agreement is very close to 100% for the clear cases and very close to 50% for the borderline cases. So it demonstrates that on one side, the encoding of the regulation is suitable to model the regulations, and also it provides a methodology to test how we encoded the parameters for the, let's say, open texture, so the terms left to the interpretation. Okay, so this is essentially, well, also we had some other applications, but again, I'm not going to speak about them, just to see that we did more work. And let me spend a very short time about what are the possible directions, future directions and opportunity, in particular, what we can do here at CQ in the near future. Okay, now, let me start with opportunities. Now, very shortly in Australia, we're going to have tranche 2 of the AML CTF regulation. So anti-money laundering and counter-terrorism regulation. And then, if I remember right, it will enter in force, so it will be effective from early 2026. And according to this new piece of legislation, 80,000 entities, new entities, will be subject to it. So essentially, there is a very large market, and essentially, there are no tools available to help them. So this is something where we can work on, and it's an opportunity to see whether we can do, and we can help small, medium, actually in particular, small enterprises, small business in Australia, and to help them to comply with AML regulation. Now, the other, and this will be a big market, and then essentially the work I'm doing in collaboration with my colleagues in Europe, and then it's about how to provide certification of conformance and compliance for AI system against the EU AI Act. So this is not applicable in Australia right now, simply because Australia is falling behind here. Again, it was leading before COVID, but now we are 2-3 years away from having an AI regulation in Australia. There was a discussion, there was some report and statement from, I think it's Department of Industry last couple of weeks, where Australia is going to have some AI regulations, and then you have to provide compliance, but it will not be effective in Australia for the next 2-3 years. Now, the market for compliance and conformance with the EU AI Act, it's estimated to be 2 billion euro per year, so 3 billion Australian dollars per year. And again, it will be an opportunity for us. Now, from the research point of view, one of the major obstacles is then you have to translate manually legislation into a formal language. And then this is not possible. We've tried a few times using different techniques, natural language processing techniques, machine learning, generative AI. Those techniques at this moment are not working. So essentially, this will be an opportunity to do some research and to see how we can improve and to build new tools to see whether we can improve the state of the art and to be able to encode regulation in a way that it's usable and processable by machine. Okay, so I'm really at the end, and this will be the final part. So, okay, if I look at the BLP listed that, well, I've worked with over 300 co-authors, so it will be too long to give a thank to all of them. But again, I have some special collaborators, and I'd like to mentions them. So I would like to thank the Bologna gang, Antonino, Monica, Giovanni, and Alberto, and many others. Also, I would like to thank, a special thank it to CQUni and for the warm welcome for having me here and for the opportunity to work here and to see what we can do for regional Australia. Finally, I would like to dedicate this presentation to my father and also to my family. Okay, that is really the end. I would like to thank you, all of you, for being here and to listen to me, and I'm open to take some questions.
Thank you very much, Guido. So that was an excellent presentation to give us an overview of application of AI in legal and compliance domain. So we welcome for questions. So we have only 3 minutes allocated time, but I'm sure many would have questions. Any questions from the floor?
It's Stephen Colbain here. I have a question for Guido. Hello, Guido. I can see this working really well where you have regulatory codes, certainly in civil law systems like in France, perhaps in the in the USA, where they have code restatements of the common law. But I'm wondering how you're going to handle common law in Australia, where you have because the law is made up essentially of legislation one side, and then the common law interpretation of it on the other. So are you dealing with the common law as a interpretation / borderline case situations and areas of doubt? Is that how you're handling the common law?
Okay. Thank you. It's a very good question, and well, probably a full answer will take another couple of hours. I will try to stick in a couple of minutes at most. Now, potentially, it is possible to encode also precedents using the technique. Whether this is really doable, feasible, and what is the complexity, it's not completely clear. So technically, it is possible. It is possible to model precedents. But I would say here, at this stage, I would focus on statutory interpretation. Now, every time you have an encoding, the encoding will be an interpretation, and essentially we'll know what are the limits of interpretation. And also in Australia, we cannot, as you know very well, we cannot have a true interpretations because the only authority, the only power who can give an authentic interpretation is the judiciary, and when a case it's put in front of them. So that will be a limitation we have in a little bit. However, what about if we have an encoding that is provided by, let's say, a government agency, and the government agency is responsible for enforcing it? Probably you can reduce the number of cases that go to court, and that it will be the legal interpretation provided by the agency, by the party who created the legislation. And then the encoding can be seen as an auxiliary, a supplementary material when a judge has to provide the judicial interpretation. Again, sorry, it's short, and then we can speak probably for a couple of hours about this, but that it will be one possible way to look at the problem.
Thank you, Guido. Santos, we might have a quick question.
Okay, yeah. Thanks, Robin. Thanks, Guido. Just want to find out about in terms of compliance, and you say confirmation for AI systems. So have you identified, for example, research or collaboration partners in Australia that you can actually pursue in terms of, looking at this aspect?
Unfortunately, not in Australia. So Australia at this moment, it's completely behind. They are not really thinking about compliance with AI systems. And simply, I've spoken with a couple of colleagues from a couple of universities. I've worked with them before, and they will agree with me. Now, if we look with, let's say, bigger players, no, at this moment, they don't care about Australia, the European legislation. They don't think it will apply to them, and so on. So I was speaking, last year I was speaking with, let's say, one of the major betting company in Australia, and he said, oh no, we don't care about the EU legislation. It's in Australia. You cannot bet in Australia from outside Australia. And then they realized that they have a couple of Sky channels, and then they are distributing their automatically generated quotes in Europe. So either they shut down those channels, or they will get huge fines from the EU because they are distributed sensitive, regulated material in EU without a test of conformance. But Australia at this moment, it's not ready, and they don't know they have a problem.
Okay, thank you.
I see, Nick, probably in a smaller scale within the university, we might be able to use this kind of technique on our compliance regulations within the university itself as well. So we'd also probably, Nick will contact you on that as well.
Ravan, you say it's a smaller example, but it's far, far more complex than any country's legislation. I found, Guido, thank you so much. I found that. I expected it to be a little bit dry. I found that presentation amazing. And I hope you're talking to lots of our colleagues across the university, across the sector, not just in IT, but of course in the School of Law, Business and Law as well.
Yeah.
Oh, thank you, Nick. Thank you very much.
Okay, thank you very much. So we will make this presentation available, the recording as well. So thank you again. So thanks, Stephen and Rob Brown. Rob is our Associate Vice President from Mackay. He's also attending. And thanks, Stephen from Business and Law School as well for attending. And thank you, everyone. Thank you, Guido, for a very fantastic presentation.
Thank you.
Thanks, Guido. Thanks, Robin. Bye-bye.